In this video, we're covering the parabola. So the first thing I want to introduce is something called quadratic equations. So an equation in which the highest power is 2 is known as a quadratic. So on your screen you can see some examples of quadratics, like y equals x squared plus 7x plus 12, y equals negative 5x squared plus 2. So when you go to graph a quadratic, this takes the form of what we call a parabola, which you can see on your screen there. Now, your basic parabola is y equals ax squared. All right. Now, a is just a constant, so some sort of number that goes out the front. So a helps to control how wide a parabola is or how narrow the parabola is. It also helps to control the concavity of the parabola. And what that means is whether it's going up or going down, increasing or decreasing. So the smaller the a value is, the wider the parabola, as you can see on the screen. So in red, you have the original y equals x squared. We add a relatively small number, a half, out the front of x squared, and you can notice that it gets wider. Now, if I increase it and make a large value for a, the parabola becomes narrower. So in your screen there, you can see y equals 4x squared in orange. So as you can see, the larger the number, the closer to the y-axis the parabola arms go. So when we say narrower or wider, this is meaning we're comparing it to our original y equals x squared. So if you have a number less than 1, you get a relatively wide parabola. Now if you get a number greater than 1, it starts to become more narrower, coming towards the y-axis. Now, the other thing to remember is that in all these examples we've had, a is positive. Now, when a is positive, the parabola is known as being concave up. And the way I like to remember this is, if a is positive, you have a smiley face. And all these parabolas here look like a smile on your face, right? So we say when a is positive, you have a smiley face, which is concave up. Now, if you have a negative, the parabola is what we call concave down. It's going down, and the way to remember it is, when it's negative, it's a sad face, so it's concave down. Now, the same things apply with whether the a is small or large when you're dealing with negatives. As you can see here in the light blue, you had a relatively small, closer to 0 number, so negative a half here. So the parabola is wider than x squared, negative x squared. Now if we have negative 4x squared, it's a lot narrower, closer to the y-axis again. So those same things apply. Now remember, when a is positive, you have a smiley face, so it's concave up. When a is negative, the parabola is a sad face, so it's concave down. When you have a smaller a value, you have a wide parabola. And when you have a large a value, you have a narrow parabola. So here we're going to look at the next step, where you might have an equation such as y equals ax squared plus c. Now, in a similar way to linear equations and graphs, you know that c is known as the y-intercept. It's our constant. Now, I like to say it's separate to the x squared. It's just plus or minus some sort of number at the end. Sometimes they try to trick you and put it at the front, but it's just a number. All right, and that number is the y-intercept. It tells us where the parabola is crossing that y-axis. So on your screen there, you can see we have y equals x squared. Now, there's no number at the end or at the front, it's just x squared, therefore we're crossing at 0. Now, if I introduce a plus 4 on it, in blue you can see y equals x squared plus 4. We're now crossing at 4. Plus 4, we're crossing the y-axis at 4. If I introduce something such as negative 3, you can see that we're crossing now at negative 3. So we covered a couple of things here in this video. So far we've covered if it's a positive, it's a smiley face. If it's a negative out the front, it's a sad face, so concave down. We know that the smaller a is, the wider the parabola is. The larger a is, the more narrow it is. Now we've also introduced the y-intercepts. We've introduced if it's a plus 4, it's crossing at 4. If it was a plus 3, it's crossing at 3. We also know that if it's a negative, it's crossing in the negative y values. So using all our knowledge, we have some examples on the screen here what I'm going to match up to where they belong. So you can pause the video now if you wanted to and give this a go, and then I'm going to do it. So the first equation we have is y equals 10x squared minus 1. Now the first thing I notice is that my x squared is positive. So I know I'm looking for a smiley face. A smiley face, so it's concave up. I know it's crossing at minus 1, so I know that the y-axis, I should be looking for where it's crossing at minus 1, and I've got a 10 there, so it's going to be pretty close together, narrow. Now, from what I've been given, our graphs there's only one that crosses at negative 1, so that's very easy to pick out where our y equals 10x squared minus 1 goes. Straight there. The next equation is y equals negative 0.5x squared. So, I know I'm dealing with a negative x squared here, so I know I'm looking for a sad face. It's 0.5 at the front, so it's going to be pretty wide. And then I can look at my examples, and fortunately for us, there's only one graph that's a negative here, which is number 3. So I know that this matches with number 3, because remember, negative is a sad face, so it's concave down. The next one is y equals x squared. I know that to be just the original one, so I'm looking for something that's positive and crossing at 0, and there's only one of those, which is 4, so I can match it there. And the last one, 3x squared, obviously it's going to be number 2, but I'm going to work it out anyway. I've got a plus 2, so I know I'm crossing at 2. I've got a positive a value, so I know it's concave up because it's a smiley face, so it has to be our 2.